Hi everyone, and welcome to another part of these Solidity tutorials. As you can remember, in the last part we had this smart contract price conversion which we worked on, and as you can remember, I said that this one works for the mainnet or testnet, but here, because we're working on a kind of a local environment, or we're working on Remix IDE, we need to change this because we're not using some kind of live price information. So we can just write another smart contract which is similar to aggregator v3 interface, and it's going to simulate for us a kind of this price information, and we will give the price fit to the smart contract so that later it can provide the necessary information. So we can get the live price from Chainlink ETH per USD, and as you can see, it's 1,913, and so we can just write another smart contract and deploy it, and then give the price fit to this smart contract so that we can run it. So in order to do so, I'm going to change this to aggregator.sol. So aggregator.sol, and so that's it. Right now we don't have any aggregator.sol, so we might face this error right here that there is no aggregator.sol, but don't worry. In this part we're going to write that kind of smart contract. So just as always, let's create a new contract in the contracts folder, and I'm going to call this the mock v3 interface .sol, and so actually aggregator.sol, because we've written aggregator.sol, but that name was better, aggregator.sol. Anyway, let's get in here and copy and paste the first two lines. So first of all, we need to write the interface related to aggregator v3 interface. So interface aggregator, and we'll write this nearly the same as what we had on the GitHub of aggregator v3 interface, but I'm gonna write it by myself so that you can also understand what's going on inside of it. And then we're going to write another contract called mock v3 interface that uses this interface. Well, that's a contract, and then that contract is going to be deployed, and it will give us the price fit. So anyway, we have the function here, function latest round data, and so parentheses, external view returns, and then open bracket. So uint 80, and you might wonder why it is uint 80. This is because we've just used the code on aggregator v3 interface from its GitHub profile. So int 256 answer, and we will have uint 256 started at, and also after that updated at. Uint 256 updated at, and then uint 80 answered in round, and here we go. So here we had parentheses instead of comma, so be careful about that. It's because it's just about the returning of the function, not the function getting started. So be careful about this. So it's just a function because we just define the function and whatever we've got inside of it and whatever it returns, because it's an interface, we're not going to focus on the function itself. So this is a simple interface, and this is what's going to return the function latest round data. But notice that aggregator v3 interface is much bigger than that. So now let's write the contract mock v3 aggregator, mock price fit contract, mock price fit, and it is using the interface aggregator v3 interface. So now let's open the brackets, and by the way, this is a square bracket. Anyway, open the brackets this way, and okay, we've got the int 256 private mock price, private underline mock price, and you are going to give this mock price to the contract by yourself, because here we do not have anything like an oracle that gives us that price, because we're not on the testnet or mainnet to provide that for us. So we're going to give that instead of the constructor before deploying the contract. So the constructor here, int 256 initial price, and then here we'll have to open the brackets, and we get the mock price from the user. So mock price initial price, and here we go. So function latest round data, external view override return, external view override returns, and so let's open the brackets. So we've got all the variables that we've defined here, so let's not write them one by one, let's copy and paste them all over here. So here we go. So now it's time to open the bracket, and here we'll have the round ID equals to 0, round ID equals to 0, got the answer equals to mock price. So the mock price here, and here we go. So started at equals to 0, updated at equals to block.timestamp, and answered in round equals to 0. So here we go. And now we've got the function set price. Function set price. It will get the int 256 price, and it is external and the mock price equals to price. Mock price equals to price. So here we go. Now we've managed to finish the contract. Now let's save this, and it's completely and successfully compiled. So right now we can just deploy a contract right over here, but notice that the first thing you get is the interface, so you need to choose the contract, and here you will need to write the initial price. So here I will copy and paste the price, so it's 1913. So let's deploy it, and here, as you can see, it's been deployed. So all we need from this one is to copy the address of it and no more, so that we can use it in the price conversion.sol. So now let's compile this smart contract. So let me see what's going on, and let me save it again. And as you can see, aggregator.sol is found, and now we can deploy it. So the address of the price feed is the address of the contract we just deployed earlier, the aggregator.sol. So we can, okay, you can copy it again, paste it here, deploy it, and as you can see, it's been deployed. So right now you have this conversion. So it converts VAY to dollars. So for example, if I choose, so you should choose a very long number because it rounds the number in case it is not a huge number. So let's convert it to dollar. As you can see, it's this amount, which makes sense. So I'm not sure how many zeros we've put here. So let me just make it like this. And as you can see, it's 1013. So it's about, okay, we've got 8 zeros, and the reason is that the decimals here is 8. So if I change this to 18 and save this and deploy it, we will see a different result. So let me copy this address again and deploy this contract again. And now if I put in 1 with 18 zeros, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So 18 zeros. So I need to check what's wrong here. Probably we can just make it smaller. So let me check what's going on here. We seem to have a problem. So there might be some kind of rounding problem or underflow overflow. We need to check that here, but it's probably because of this 18 over here. Anyway, this number that you put in here is the number of decimals. Okay, so it's the scientific number that you put in here, and that is going to determine how many zeros we need to put in there in order to convert the price. But for Ethereum, we've got the decimals is 18, so each 10 to the power of 18 ways will be 1 Ethereum. So even if I put any number of zeros here, it will still be an error. So I guess I will show you what the problem is. So instead we can write 10 to the power of 18 here, or let's first try 8 and then test the 18. So let me delete this one, copy it and paste it over here, deploy the contract, and so let's now check the VAY to dollar. So let's put in 8 zeros, convert to VAY. So there still seems to be a problem. Let us change all of this all together, and let's deploy the aggregator.sol again. Here, mock price and aggregator v3 interface. So actually this is the interface. I need to choose the price, and the price is this one. 1913. So deploy it, copy the contract, and now price conversion. So now let's choose the price conversion contract. So this one is that, and paste the address or price fee address. So here we go. I'm gonna check this again once again, and if there's a problem, we'll change the format of writing. So here I can write a number, and as you can see, it worked. So it's probably because of the deployment. We needed to deploy it again. So as you can see, the number of decimals show us the numbers. So it's 8 zeros, I guess. Yes, there are 8 zeros, and and because of this number, which is 8, we'll have 1913. But if I change this to 10 to the power of 18, there is this problem. There might be this problem that we will have the overflow. So let's save this one and try again. So there we go. So anyway, now let's try with a number, convert it to a. It's still 0, so it works. Yes. So now if I put in 18 zeros here, we'll get the number that we want. So here we should have 18 zeros. So let me try again. 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 and 1 2 3. So let's try again. As you can see, it's now works with 18 decimals. So you can write it this way too, and the way we wrote it earlier was also fine, but the problem was that we needed to deploy this contract again. So no problem anyway, and the smart contracts work. So this way we managed to convert the price from the way to dollar, and so this contract is important because we can just use it in the previous contracts for bonding curve the Sol contracts here, because here we would calculate the Ethereum amount, but what if we want to convert it to another number, right? What if you want to convert it to dollar, and so let the price be constant relative to dollar. So we'll work on these kind of smart contracts in the later tutorials. So that's it for this part, and until the next one, goodbye.